We're going to look at the binomial theorem and using Pascal's triangle to expand something like this. If you had an x plus y all to the fifth power, be an x plus y times 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 an x plus y. You'd have to FOIL the first two. That's the first two here then. Then you'd have to take this times your third one, get that answer. Take that, then times your fourth one, get that big answer. Then take that big answer times your fifth one. Now, a lot of people would find that to be more work than they really care to do. Another option you can do is to use this formula. It has the summation notation that we've looked at a little bit in this chapter. However, some people are a little scared by that formula. So what we're going to do is we're going to look at Pascal's triangle. It's going to accomplish the same thing as what's referred to as the binomial theorem. So whenever on a test or in your homework you see use the binomial theorem, just be aware that, excuse me here, you can always use Pascal's triangle. Pascal's triangle is this here. It starts with the 1 at the top, then 1's go down the diagonals. Now, 1 plus 1 is 2, so you get the middle number underneath them. Or here, how do you get the 3? From the 1 and the 2. How do you get this 3? From the 2 and the 1. And it continues that pattern all the way down. So you can easily generate this. So we know we have 1's going down here. How do we get this 5? Comes from the 1 and the 4 added together. How do we get the 10? We take the 4 plus the 6 and add it together. How do we get this 10? We take the 6 plus the 4 and add it together. How do we get this 5? It's the 4 plus the 1 added together. So if we continue to do that, we end up getting Pascal's triangle. So here, this is 6, then 15, 20, 15, 6. Here, that's 7, 21, 35, 35, 21, 7. Or down here, these two is 8, 28, 56, 70, 56, 28, 8, and so on and so on and so on. It goes on and on and on. Now, let's use Pascal's triangle to help us expand something like this here that we started out with. You would want to go ahead and start with your fifth row. Now, your row is always given to you by the second number in. So this one here, since it has a 4 as the second number in, is your fourth row. This one here is your third row because it's second number in. This one's your seventh row. It's the second number in. So we need to have this row right here because the second number in is 5. So let's go ahead and write down that fifth row. So we have the 1, and then we'll leave some space and go plus 5, and then space plus 10, space plus 10. So the red numbers here are all the fifth row of Pascal's triangle. Now, you have an x in the beginning. So you're going to put an x here in the beginning. It's a fifth power, so you're going to put the fifth power. Now you want to decrease your exponent by 1 each time. So this one here is not going to be an x to the fifth, but an x to the fourth. Then it'll be an x cubed, and an x squared, and an x to the first, and then it's an x to the 0. Your y is at the end, so you got to start at the end, and you're going to put down a y. But what's your power? It's 5. And then you want to go backwards, decreasing your exponent on the y. So it'd be a y to the fourth, y cubed, y squared, y to the first, y to the 0. So a little bit of simplification. We don't really need the times 1. We also know y to the 0 is 1. Really no simplification we can do here other than not write your exponent of the first. That doesn't simplify. And then we move all the way over here to the very end. it simplifies with not having to go times 1 and x to the first, or 0, which is 1. We don't have to write. So this is your answer. As a side note here, suppose you had 12 factorial over 4 factorial. 12 factorial means 12 times 11 times 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1. So it's just multiplying all the numbers together between 12 and 1, but only integers, no decimals or fractions. 4 factorial will be 4 times 3 times 2 times 1. Notice you have a 1 top and bottom, a 2 top and bottom, a 3 top and bottom, and a 4 top and bottom, so they drop out. So the only thing you're left with then is really just this. And to work that out, you can use your calculator if you want, and you would get this number right here. Needless to say, it's not one you want to do in your head. This one here is to the 7th. Pascal's triangle only works when it's an addition sign in here, not subtraction. So we need to rewrite that our subtraction is adding the opposite. So let's go ahead and take the 7th row, because your exponent 7, so we have our 1, our 7, our 21, our 35, 35, 21, our 7, and our 1. Now our a's in the beginning, you're going to start with that a to the exponent, so a to the 7th. Then decrease your exponent by 1 each time, a to the 6th, a to the 5th, a to the 4th, a cubed, a squared, a to the 1st, then there'd be no a. Then here at the end, we have a negative c, that's to the 7th. So you got to go to the end, you go negative c to the 7th. And then you got to go backwards, decreasing your exponent by 1. So it'd be a negative c to the 6th, to the 5th, to the 4th, to the 3rd, to the 2nd, and to the 1st. Now all we're going to do is a little bit of simplifying. We don't have to have our 1 here. A negative times this makes it minus 7 a to the 6c. A negative squared is positive, so it does not switch our sign. A negative cubed changes your sign in front, and so on. A negative to an even power never changes your sign. However, a negative to an odd power always switches the sign in front. So on this one here, to work this one out, you don't have to list everything. You only want the 5th term. I'm going to use my calculator to help generate the 9th row. If you don't have a calculator that does this, then you just go back here and you continue to expand your Pascal's triangle down into the 9th row. But I'm going to show you another option that you have. So pull our calculator up, go to your y equals. I have a few things in here I'll get rid of. Now we're going to go ahead and type in our exponent of 9. Then we're going to hit math. Arrow to the left once. Down to the NCR. Then hit X. Now I'm not sure what you guys have been doing with your table before. Once you've done this once, you shouldn't need to do it again. But let's go second window. We need to start at 0. Needs to be at a delta table of 1. These both need to be in auto. If they are, great. Don't worry about it. Just go ahead and do the next thing, a second graph, which is your table. Here is the 9th row of Pascal's triangle, right here. We're looking for our 5th term. Well, here's our 1st, 2nd, 3rd, 4th, 5th, which is when the input is 4. So don't look at the numbers on the left, count down from the top. So we get a 126. Now, we know we're going to then have a 2a here, but a 2a to the what power? Well, you knew here it would be to the 9th, and then you decrease it by 1, be the 8th, 7th, 6th, and then in this case it's 5th. Okay? So it's to the 5th power. Now, we also need to have a 3x to the what power? Well, this exponent and this exponent here that I'm hiding right now always have to add up together to give you this whole original number of 9. So 5 plus what is 9, and that's 4. So now all we have to do is just go ahead and work that out. Your 2 to the 5th is 32. Your 3 to the 4th is 81. So take an 81 times a 32 times your 126. And you get this nice big number. Still with your a to the 5th and your x to the 4th. So let's look at this one here. It's 4th power, so you want to write down the 4th row, and your 4th row would be your 1, your 4, your 6, your 4, and your 1. You have a 2x in the beginning, so put it to the 4th power. 2x then to the 3rd, 2x to the 2nd, and then 2x to the 1st. You have a negative 3y at the end, so put that to the 4th, negative 3y to the 4th at the end. Then it would be to the 3rd, and then to the 2nd, and then to the 1st. Then we want to simplify. 2 to the 4th is 16, still with your x to the 4th. A negative times all these positives is a negative. Your 3 times a 2 cubed, which is an 8, so a 3 times an 8 times a 4. A negative squared does not change your sign in front, but you'd have then a 3 squared, which is 9, a 2 squared, which is 4, times a 6. A negative to an odd power, it's going to switch the sign in front. Be a 3 cubed, which is 27, times a 2 times a 4. And then you'd have a negative to an even power. It won't switch your sign. Then you just have a 3 to the 4th, which is an 81.